Okay, we're doing quiz 9.1, 9.2. Really just quiz 9.2. 9.1 was just the basics, which gets incorporated into both 9.2 and 9.3, so we're just doing it here. All right, let's see what we got. Hard drive manufacturer claims 13% of their hard drives fail within the first year. Sample of 35 hard drives, 8 fail within the first year. Is there sufficient evidence to conclude the percentage is larger than the company's claim? Okay, and they're walking us through the steps. First step being stating the null and alternative hypotheses. We have three tests now. I'm sorry, I'm doing this after chapter 10. So, but as far as chapter 9 goes, you have two tests: testing for the population proportion, testing for the population mean, and then in chapter 10 you have testing if a distribution is as claimed via the chi-square test, goodness of fit test specifically. And so we have three tests to worry about, and you have to choose whenever they say perform a hypothesis test, or it refers to null and alternative. Anyway, are we looking at averages of things? Are we looking at a distribution of different categories of things? Or are we looking at percentages of things? And we're looking at percentages of hard drives that fail within the first year. So we're doing a test for proportions. So you're looking at P, and you're speculating or drawing conclusions about this population proportion P of all the hard drives that fail within the first year of this manufacturer. They claim it's 13%, so we're going to go with their claim as a null. Change it to a decimal form always. We're always going to be working in the decimal form of percentages, but we will think of it like percentages. So P is equal to 0.13 is the claim, and that's our null. Our alternative will be some sort of comparison with 0.13, depending whether we want to test whether it's less than claimed, which is better, more than claimed, which is worse for us, the hard drive, the consumer, or not equal to, which is just both ways and just seeing if they're lying or not. Larger than the company's claim. It says, is there sufficient evidence to conclude that blah, blah, blah is larger than? So we're looking for if that P is greater than their claim of 0.13. That's a right tail test. All right, we're ready for number 2. So I didn't get to do a problem or I didn't have one like this in my notes, but number 2 says to calculate the p-value of the test statistic. That's actually 2 steps in one. So this is step 1. Step 2 in the process was to calculate the test statistic, and then 3 was to get the p-value of that, and then 4 was your conclusion. So number 2 is actually combining 2 things in one. We've got to do the test statistic, and you have the z1, the t1, and the chi-squared one. This is a z1. Ooh, I don't want to write. Oh, I'll write out the formula. It's p hat minus p over the square root of, and be careful, it's p and q over n. And that's 2 separate proportions that are involved here. Make sure you know which is which. Note that you need p hat, you need p up top, subtracting in that order. You will need q on the bottom, that's 1 minus p, not 1 minus p hat, and n the sample size. Okay, I'm going to go ahead and do that first, because how many hard drives did they test? They tested 35, 8 failed. So your sample size is all of them, the ones that failed and the ones that didn't. So 35 hard drives in your sample. Now, P and P hat. Be careful. P hat is the sample proportion, the percentage of your sample. And then P is the population proportion, the proportion of all hard drives that fail. And P is based on their claim, so P is equal to 0.13. We assume that their claim is valid as of now. We do our computations assuming their claim is valid and that the percentage of all their hard drives that will fail is 0.13. That makes Q1 minus that, 0.87. And then P hat is the sample proportion. Sometimes they'll give it that to you as a percentage. Sometimes they'll make you compute it yourself. And here we have 35 hard drives in our sample, 8 failed, and we want P hat the proportion of that sample that failed. So here it's 8 out of 35. So be conscious of that. The P hat is for the sample, the percent of the sample that failed. 8 divided by 35 is a proportion, so we'll do the 3 places, 2285. I'll run this to 229. 22.9% of the sample hard drives failed. That is higher than 13%, but is it enough for us to conclude? That's based on a p-value. So let's see. What am I doing? Z. P hat goes first. P goes second. On the bottom is P and Q divided by N. That's what we're computing. Be careful with making sure you use parentheses around the top. 229 minus 0.13. Okay, I think I'm good. 1.742. This is a z-score. Z-scores are the 3 places. And that's the z-score. That's our test statistic. Okay. Let's start quick because that's an important thing, but it's not the it's not the answer for number 2. Just be aware of that because now I need to get a p-value of that. Still on number 2. So again, it's 2 steps in 1 essentially. I'm going to draw a picture. And what picture is that? It's the standard normal curve. Why am I doing that one? Because on your sheet it says that this z-score, this z-test statistic, has a distribution that is standard normal. Normal with mean 0, standard deviation 1. So it's the one with 0, 1, 2, 3, negative 1, negative 2, negative 3. I'm not going to draw all that because what I want to know is where that is, how far away, how unusual it is based on the tail probability. And so every time you take a sample of 35 hard drives, the percent that's going to fail is going to be different every time because it's random. Failure of hard drives is fairly random. If you get exactly what they claim, supposedly 13% of all their hard drives fail, and so in theory you should get something around there. You shouldn't have 100% of your hard drives failing, or they're definitely lying. You shouldn't have 0% failing. You should have 13%, maybe 15%, maybe 8%, something around there. 22 seems pretty high, just intuitively, but I'm not going to go with my intuition. I'm going to compute it precisely. So if this came out to 13, exactly what they claim, you get a z-score of 0. That's exactly what they claim. If you had below that, like 0.08, you get a z-score that's out here, which is good, because then your p-value is going to be there, and you're definitely going to not reject, which means that you definitely believe them. Because if 8% of your sample fail, that's definitely corroborating that 13% seems reasonable. In fact, it seems that they're doing better than the 13%. But if you do get a p-hat that's higher than their claim, that's starting to show evidence that they were lying. Now if you get 0.15, 15%, slightly above what they claimed, you probably let it slide. That's going to be a z-score just above 0 to the right, but not that far. And you'll get a high p-value and probably still not reject. If you get something way higher, like 0.229, that seems like it's pretty far off. And that's going to be indicated by a z-score that's further away from 0 to the right, because it's at any percent that's higher than what they claim is going to give you z-scores that are positive, and the higher, the further out here. And the more likely we are to reject, the stronger evidence. Anyway, my p-value, the picture helps strictly because I need to do normal CDF. It's a normal distribution. I've got to do my lower bound, which is at z-score, because I'm doing a right tail test. Not because it's close to the right tail, but because right here we're testing if it's above the 13% they claim. 1742. My upper is infinity, 10 to the 99, and if you have the thing, just make sure your menu, your mean and standard deviation are set to 0 and 1, because this is a z-score on your standard normal curve. Let me label that. Okay, let me compute that, and that's my p-value. That's the answer for number 2. Mm. 0.041, 0.0407. I'm going to do 3 places. 0.41. That's 4.1%. So there's a 4.1% chance that if they're telling the truth, there's a 4.1% chance that you get something in that range by random chance. Now that's pretty low, but we have to look at our significance level. So we're done with number 2. That is your answer for number 2. Number 3, should we reject the 5% significance level? So here they're giving us different significance levels. Our p-value is the same for this whole entire quiz, unless they do a different sample and they give us a different data to work with. We're using 0.041. What's changing between number 3 and number 5 is the significance level. Here it's 0.05, and that's less than that. Anything below 5% is enough evidence, sufficient evidence. So yes, sufficient evidence to reject the null. Sufficient being anything less than any p-value that's less than 5%. We do not believe them in this situation. So this is far enough out that we conclude that they are lying, they are false advertising, and that the percentage of their hard drive failures is higher than they claim. All right, that's it. We reject null. If you want to answer in yes, we have sufficient evidence. We're always looking for, we always assume this is true until we have sufficient evidence to reject it. If we don't, we have insufficient evidence to reject the null. 4, an error problem. Okay, we reject it here. But then I need to see whether this hypothetical is saying HO is true or not. So let me read it off. If the true percentage of hard drive failures within the first year is greater than 13%, our null says it's equal to 13%. This is saying, let me write it out. I'm going to summarize it. Suppose P is greater than 0.13 is what they're saying in this hypothetical. That means the null is false. So this is saying suppose HO was false all along. We rejected it. It means suppose the company was lying and we called them out and sued them for false advertising. What's our error? That is definitely the correct decision. I don't need to look it up. Okay. I'm going to erase here and do the rest over here. I don't need any of that, but I do need that p-value because now it's just doing the same thing, using the same data. They didn't give us any new data set to work with or new sample data, so should we reject with the same data and the same p-value, should we reject the 1% significance level? 1% is a higher standard of evidence, and you would only reject with that higher standard if you have a p-value below 1%, and that's really strong evidence that they're lying. We don't have that. We don't meet that higher standard now. So at a loose standard, we're going to sue them. At a higher standard, we are not going to. No. You have insufficient evidence. You're not going to win in court, so you're not going to reject a null, and you're not going to file a lawsuit. Different conclusion based on a different significance level, a different standard of evidence. All right, number 6. Make sure you read it because maybe I changed the wording a little bit on this. So suppose the failures are greater than 13%. So again, it's saying HO is false. It is literally the same thing as number 4. Except our decision is different now. HO is false. That's what they're saying again. Suppose the percentage was greater than 13%, which means the null, their claim was false all along. We did not reject something that was false. That is definitely an error. What type of error? Oh man, I erased it. Let me see if I can remember this. Type 2. Look up on your chart. I'm going to go by memory, and then I'll go along and look at my thing. I'm pretty sure it's type 2. Type 2, yep. Okay. So we're good. Anyway,
That's it for our 9.1, 9.2 quiz, and then we'll do 9.3. But again, be aware on your exam you won't know which tests you use. So the important thing is proportions. It's this test with the z statistic, and means, which is the one with the t statistic, and it's in that section labeled hypothesis testing in your formula sheet.